In this video, I'm going to be covering section 7.2, and our objectives are to learn how to determine the domain and the range of a function, and to understand some of the restrictions on the domain, and also to understand what piecewise functions are. So remember that a domain is the set of possible inputs for a function, and the range is the set of possible outputs for a function. And a piecewise function, we need a definition for that. It's a function that's defined in two or more ways for different sets of the domain. So we'll have a piece of the domain where the function rule is one way, and then another piece of the domain which has a different function rule. Most of them have two, maybe three, but I mean, theoretically, you could have 500 different ones in a piecewise function. You won't see that. You'll see 2 or 3. Okay? So the first thing we want to do is look at this graph of a function. And we want to look at what the domain and what the range is on this. Well, the domain is going to be from the lowest x value that we have up to the highest x value that we have. But notice how I put my little end pieces here, but those are arrows. It actually goes on and on and on. The arrows say that this doesn't end. So while we only see a piece of our function, the domain is all real numbers. Started writing that wrong and it was just never going to come back. So, all real numbers. Okay? The range, on the other hand, is the y values. And for y, what we see on our graph is from here to here. But there are arrows, so it's going to keep going higher, and it's going to keep going lower. So the range is also all real numbers. So be careful when you have arrows. They mean something. Okay, domain and range on this one. Why do I still have this up? This is why I still have this up. So I'm going to put my nice little hand here, and I'm going to make this a little bit smaller, but try to center it again. And I'm going to bring it over to here so we can look at it. First of all, let's name all of the ordered pairs we have. We have A, which is, well, phooey. Remember to change your tools when you're doing this. A is the ordered pair -4, -2. B is the ordered pair 2, -5. C is the ordered pair -3, 4. D is the ordered pair 1, 5. And E is the ordered pair 5, 0. So our domain, the set of all inputs that went into this function, is -4, 2, -3, 1, 5. And you'd actually want to clean that up. I have to put set brackets on it. You'd actually want to clean that up and put it -4, -3, 1, 2, 5. There's your domain. The range, we're going to take all the y values because that's all the outputs. And I'm going to try to put this in order as I go. -5, -2, 0, 4, 5. So you can have a graph like that and be asked to look for the domain and the range. And again, the domain is all the x's that possibly went into it, and the range is all the possible y values. Now restrictions, I still have this all small. Restrictions on a domain are an interesting concept. Because when you get into real-life applications of domain and range, when you get into the real-life stuff, what are you going to find? Well, you're going to find that certain things just can't take on certain values, even if they work mathematically in the equations that you have. It makes no sense to talk about negative time, or negative distance, or negative age, or negative height, or height above 10 feet if you're talking about a human being, because people just aren't that tall. So there are some kind of limiting factors in real-world applications, and isn't that where we really want to go with our math, is into those real-world applications? Where does this work when the rubber meets the road out there when I'm doing stuff? So those are some kinds of restrictions that you're going to need to be thinking about as you do those things. Okay, this is a piecewise function. G of x equals, and what I could not get the stupid Microsoft Word to let me do is put a big bracket there. But you have this piecewise function where g of x is defined one way as x minus 5 if x is less than or equal to 5. But it's defined as 3x if x is greater than 5. So there's that break at 5. At 5, you switch to a different function. So when you are evaluating a piecewise function, you have to know where you are so you know what rule to use. Well, at g of 0, 0 is less than or equal to 5. So we'll do g of 0 equals 0 minus 5. G of 0 equals negative 5. 5 is still in here because this has a less than or equal to. That means 5 is included in this one. So g of 5 equals 5 minus 5. G of 5 equals 0. But 6 is down here in this piece. 6 is greater than 5. So here g of x is 3x. So g of 6 would be 3 times 6. G of 6 is 18. Now what's the domain of this function? What are the possible inputs of this function? Well, I want you to realize that the domain of this function is the set of real numbers. Probably shouldn't have used yellow. That doesn't really show up. I'll go back and go over it in black. It's a set of real numbers. It's just at a certain point the function rule changes. But we still know that we can put in any real number and get a unique, one and only one value that corresponds to that number. So by definition, we have a complete function that has a domain that is a set of all the real numbers, even though it breaks at 5 into a different rule.